This is for the ECE 202 course at Chaos University. The date is May 2022. Today I'm going to show you how to open Cadence and how to create schematic in 65 TSMC nanotechnology node. Then we will build, assemble, we will do a test bench, then the final we will make a layout, do the DRC, LVS, and finally the BICS. Let's go to this file. I already create the file. We go to EC2, then we go create file for 65 nanotechnology, open the terminal here. Then I tab model load Cadence 2021. Okay, so I already create this library. You can create it from here, new library, then you create the library and you attach it. Let's create it together. 82 version 2. Then I will attach it to a library, the BDK library. So I'm gonna attach it to TSMC 65 nanotechnology. Okay. So now I need to create schematic cell view. You can create, let's make an inverter, 2 transistor simple inverter, use schematic, everything is set up correctly, make it bigger. Then we insert, you can insert from here or you press I. We go to our library, the library that is CMC. We will choose the NCH, which is with the low voltage LVT. This is NMOS, low voltage. We place it here. Then we go again to I. We choose P. This is BMOS, low voltage. We place it here. Then we connect the gate together. Now we are creating inverter. Drain with the drain. This should be connected to VDD, and this should be connected to the ground, and this to the lowest voltage, which is ground in our case, and this is the highest voltage, which is VDD in this case. We make a wire for the input, make a wire for the output. Now what else we can do? We can give it pin. So we will give input pin, we call it in, and this is input. Then we can give out, we change this to out. Then we give VDD, then space, then ground. If you have the same thing shared, like for example now in out, VDD ground, we need both. So this is VDD, you can rotate it by click R, then we can rotate it and connect it here. Okay, now we have this already is created. We will use the same default values, which is 60 nano for the length, 200 for the width. We save and check everything is okay, perfect. Then we can create symbol from it. You go create cell view, from cell view. We name it inverter the same. We will take this and make it below, I mean the bottom, then press OK. Now it give us the symbol. Let's make it bigger. F to make it in the middle. Everything is okay. We can use the same, or we can make it as an inverter, like as a triangle. We go here and you can cancel this one. You will have this one. You can make it like this. just to make it like the standard things. Make this here, double click here, double click here. You can move this by taking this and move it down. Not this one, move it up. Then save and check, and you can go back to schematic by press equal on the keyboard. So now we are back. So now we are done. We created the symbol. Let's close it. Let's test it. Let's create a new cell view. Name it test bench schematic. Everything is okay. Make it bigger. Hit I. Now we go to our library, which is this one. We choose the inverter that we have created and symbol. Okay, and we look, it is a nice inverter. Now we have the output. We can connect it to the load, maybe a capacitor or resistor, but in this case we will have a capacitor, the input. Then we hit I, we go to analog lib. We will choose the V source as an input. We hide it and put it here. We use VDC. This we will have it for the supply voltage here. Then we need a ground. GND from analog lib. This is a ground. We need a ground here. We need a ground here. We need a ground here. Let's make it like this to standardize everything. And lastly, we need the capacitor, KAB. We put it here. And we need another ground. We can copy it from here. Just press C and you can copy it. For wire W from the keyboard, then here. Perfect. So now we need as well here. Okay, now we need to make an look at this one. We need to connect it perfectly, otherwise it will give you an error. Let's go here first. Give it VDD. So in the requirement and the project file project, it was 1.8 the VDD. This is an inverter, but we will apply the same thing. And here we need to provide a square wave. We don't have a square wave here, so we can choose pulse. Delay, we don't care. The zero value will give it 0. The upper value will give it 1.2 because this is 65 nanotechnology, it cannot handle more. Period of waveform, let's give it for nano. Rising, we can give 0 or small value for as a reality. 10 pico, 5 pico, it depends about the input. And here is the same. And this is the half of the waveform. Let's make it 2 nano. Okay. Now let's say okay. Save and check. Everything is okay. Let's go and see it out. Oh, let's change this one to make it small. Let's make it 100 femto to see the effect of the capacitance. Okay. Save and check. Now we will make the test. Create a new. Leave the same name. Okay, you can go to tests, create the test. It asks you which design that you wanted to do the test on. Okay, now take you inside the test. Let's choose the analysis that we need. We need in this case transient analysis. We'll give it 20 nano since the one clock is 4 nano, so we can have 5 cycle. Let's leave it moderate. Once you have more, you want to have more accurate result, you can go to conservative, but moderate is faster for initial test. Then once you need more accurate result you go here after you make sure your design is working fine. Okay, now let's go for the output. Let's go and name the net. Hit L, then write out space in, height out in. Save and check. Let's go back. Okay, I believe it will, everything is okay. Click here, then let's make because I'm using the RSWS, which is my WS, the server, the shared server in Coast. It might take some time, but if I have time, I will go back again and cut it to just make it easier and faster for the students and the user to not waste their time. I'm trying just to talk anything, just to speak, to not make you bored. But let's wait. Okay, it is finished now. Why is none? We did not make any output, so we can go and send the output. Like we can go right click. How can we make the output here? Plot voltage transient. But because it is high, the time is not enough to make the load to go up. Let's change the load to make it 1 pm2 to see. Check and save. Then last time we forgot to do the output, so let's press the output to be plotted from here and here. Because if the input is 1, we expect to go 0, so we need to input and output to be drawn. Okay, so now let's run it again. Okay. You might, because I'm using the server 13, it's supposed to be, maybe the memory is quite full, that's why it is slow. But if you end up with lower memory, so you might have a faster response. Now it is done. Let's draw it. Okay, let's see. So now you can see that once the n is 1, the output is 0, so that functionality is working. Okay, so now let's make the layout. I will record another video for layout to just save your time.